In this video, we will be discussing Dalton's law. The question that we're going to investigate is how are the pressures of each individual gas fit into the picture of the total pressure of a system. So we have talked about gas pressure, and gas pressure is the resultant from gas particles colliding into each other and into the walls of their container. Particles in a mixture of gas all collide into the walls of a container and all have the same average kinetic energy. The gas in a system will have a temperature, and that temperature is proportional to the average kinetic energy. So it doesn't matter which type of gas particle it is in a system, they will all have the same average kinetic energy. Partial pressure we will define as the contribution of each gas in a mixture to the overall pressure. So in a mixture of gases, the total pressure is the sum of the partial pressures of the gases. This is Dalton's law. And we'll represent that mathematically with pressure total, and that's P sub T, equals P1 plus P2 plus P3, so on and so forth. So we're simply stating that to get the total pressure, we simply add all of the components together. So we take the partial pressure of each gas present in the system, add them together, and we get the total pressure. So if we look at the composition of dry air, there are four primary components of air. Nitrogen is far and away the most abundant. Oxygen is fairly abundant, and then there's a little bit of carbon dioxide, and then argon and others will lump all in together. So if we look at the volume, we can see how that relates to the partial pressure. All right, the total air pressure at standard pressure is about 101.3, and that is directly proportional to the 100% in the volume column, and then they're broken down in that ratio. So each of them will have slightly more partial pressure than the volume percent that it takes up of the system. So if you add the partial pressure of nitrogen, oxygen, CO2, and then the rest of them together, we get 101.3, in this case, kilopascals. So we'll jump right into a sample problem. And here we have a gas mixture of hydrogen, helium, neon, and argon, and we're given the total pressure of 93.6 kilopascals. The partial pressures of helium, neon, and argon are given to us, and we are to calculate the hydrogen. So we will use Dalton's law, and in this case there are four partial pressures. So we have P total equals P1 plus P2 plus P3 plus P4. So we'll start trying to pick out information. We'll start with the partial pressures first. So for P2, I took 15.4, which is the partial pressure of helium. I left P1 open because in the beginning of the question we identified that as hydrogen, and that's what we're trying to solve for. The next partial pressure given is for neon. It's 25.7 kilopascals. And finally, argon is 35.6. Now we can't solve for P1 quite yet because we haven't entered in P total. So in the first or the second sentence of the question, we are told that the total pressure is 93.6. We put that in at the beginning and solve for P1, and it comes out to 16.9 kilopascals. A couple of hints. Make sure that all of your units of pressure are consistent. You can use any unit for pressure here. It could be millimeters of mercury, atmospheres, or kilopascals, but they need to be the same. That is the key. This law can account for any number of gases. You could have 100 different gases in a system, and you would be able to enter in all of their partial pressures to get the total pressure or to solve for one of them. Check the comments for further practice problems.